Right, so far we have learned that solving two systems means to find where two linear equations intersect. We've solved two systems by graphing and substitution. Now it's time to learn how to solve using elimination. So at the end of this lesson, you will be able to solve a system of linear equations using elimination. All right, when do we use elimination? When both equations are in standard form would be an appropriate time for us to use elimination. And elimination is pretty much exactly what it says. We are going to eliminate something from our problem to make our problem easier to work. All right, so we are just going to plug right into an example here. The example says to solve the system. So again, we're looking for the point of intersection. The numbers that I'm going to put in this problem are 5 and 7, and you will always be given those numbers. It's not something that you're going to have to come up with on your own. All right, so what we are going to do with this, just watch me on this first one and then I'll explain why I did what I did. I'm going to draw one line and we're going to pretend like this is like a addition problem, and what I'm going to do is put a plus sign in between the two problems. I'm actually going to be adding the two problems together. So just watch when I do this. 4x plus 2x will give us 6x. 3y plus negative 3y disappears, and then I get equals 5 plus 7 gives me 12. So notice when I do that, it was called elimination because my y's were eliminated from the problem. And now what I can do, I'll divide both sides by 6, and I already have half of my answer done. X will equal 2. Right, then from here, just like we did when we did substitution, we're only halfway done because we have to find the other value. You may go up into either one of those equations. I usually just pick the top one because that's easiest. So x equals 2, so instead of x, we'll put 2. So if I rewrite that, 4 times 2 is 8, plus 3y equals 5, and then I'm going to be solving for y. So we'll subtract 8 from both sides. So we'll get 3y equals negative 3. And then we'll divide both sides by 3, and I will get y is equal to negative 1. So my point of intersection is 2, negative 1. That's where those two lines would cross each other. Just a couple things I want you to notice. We were able to do this because both of the y's said 3y. That made that possible. All right, let's try our next one. We've got 3x plus 4y equals 23. And negative 3x plus 5y equals 22. It would be great at this point in time if you pause the video and try it on your own. There's going to be lots of times where I'll be asking you, I'll usually do a problem and then I'll ask you to pause and try one on your own. So just like I did the last one, see if you can pause it and get this one. All right, I noticed that the x's are the same, so all I need to do is just add those two equations together. And when I do that, 3x plus negative 3x, they are gone. 4y plus 5y is 9y, and 23 plus 22 is 45. So now I can go ahead, divide both sides by 9, and I'll get y is equal to 5. So we're halfway done. So now I can go into either equation, it doesn't matter. So I'm going to go to the top one. I know my y is 5. Make sure you don't put it in for the wrong letter. It's in for y. So we're going to have 3x plus 4 times 5 is 20 equals 23. And then from here we're going to subtract 20 from both sides. So I'll get 3x is equal to 3, and then we'll divide both sides by 3, and I will get x is equal to 1. So my point of intersection on this one is going to be 1, 5, because we do write it as a point x, y. So that's where the two lines would cross. And again, this worked because my x's were the same but opposites. All right, let's try another one. We've got 3x plus 2y is equal to negative 6, and then we've got 5x plus 2y is equal to negative 14. All right, now in this one, before you start trying it by yourself, notice if I just added these two equations like before, I'd get 3x plus 5x is 8x, and 2y plus 2y is 4y. Nothing eliminates, so we've got a problem. But what I do notice, what would happen if I subtracted the two equations? So let's try that. 3x minus 5x is negative 2x. 2y minus 2y is nothing. They did eliminate, yay. And then negative 6 minus negative 14 is 8, because remember this will be negative 6 that will actually turn into plus a positive 14. Be very careful when we're doing that. Okay, so now we're ready to solve. I'm going to divide both sides by negative 2, and I get x is equal to negative 4. And then once again, I'm halfway done. I'm ready to go back up into one of the equations. Again, my preferred equation is just the first one. And I know my x is negative 4, so I'm putting it in for the x. 3 times negative 4 is negative 12, plus 2y is equal to negative 6. And then from here I'm going to solve for y. So I'll add 12 to both sides. I'll get 2y is equal to 6, and then we'll divide both sides by 2, and then we'll get y is equal to 3. So my point of intersection will be negative 4, 3. That's where those two lines would cross. And one thing I'll just point out again, the important thing was that the y's were the same value. So if the y's are the same value, we'll either add them or we will subtract them. All right, problem 4, let's have 5x plus 6y is equal to 28, and 7x plus 6y is equal to 32. Would you please on this one pause the video? I'd like you to try it like I did number 3 and see how you do on it. Alright, just like in number 3, my y's are the same, but they're the same sign. So to get them to go away, I'm going to have to subtract them. So this time, instead of adding, we'll subtract again. 5x minus 7x is negative 2x. 6y minus 6y is nothing. And then equals 28 minus 32 is negative 4. And I'll divide both sides by negative 2, and I will get x is equal to 2. Halfway done. Go back up to either equation. X is 2, so make sure you put it in for the right variable. So 5 times 2 is 10, plus 6y equals 28. I'm then going to subtract 10 from both sides. I'll get 6y is equal to 18. I'll then divide both sides by 6, and I get y is equal to 3. So my point of intersection of these two lines is the point 2, 3. And so hopefully now you're becoming somewhat familiar by solving systems using elimination.